Hi gang, I'm going to show you an easy way to determine whether something is positively charged or negatively charged. A comment by user Slovenija12345 recently made me wonder what polarity the front of my cathode ray TV tube was. I knew it was charged, but didn't know if it was positively charged or negatively charged. You'll need an electroscope, which you can quickly build using parts from around the house. This one's made with a glass jar, a bit of aluminum foil, a stiff bare wire, a plastic cover and a plastic tube, and some tape. In my How to Make an Electroscope video, I show you how to make this one. You'll also need a plastic Coke bottle and a head of hair. The first thing you need to do is bring the terminal of the electroscope near the charged object. Notice that the electroscope leaves separate. While still holding it near the charged object, touch the terminal with your finger, and then take your finger away. Notice that the leaves come back together. Now move the electroscope away. It's important that you do it in that order. Remove your finger before moving the electroscope away, not after. Notice that when you move the electroscope away from the charged object, the leaves spread apart again. The electroscope is now charged. This is called inductive charging, and in my inductive charging using an electroscope video, I explain it in more detail. The important thing to know is that the electroscope now has the opposite charge that the charged object does. If the charged object is positive, then the electroscope is now negative. If the charged object is negative, then the electroscope is now positive. But which one is it? We'll find out in the next step. We know that if we rub the plastic Coke bottle against our hair, the Coke bottle will become negatively charged. We know that from the triboelectric series, and you can see it here. The Coke bottle is made of polyethylene, here at the negative end of the series, and hair is at the positive end. If we bring our negatively charged Coke bottle near the terminal of our electroscope, then it'll repel electrons from the terminal down to the leaves. Electrons are negatively charged. If the leaves are positively charged, then these new negative electrons will make them less positively charged, and the leaves will come together. If the leaves are negatively charged, then these new negative electrons will make them more negatively charged, and the leaves will spread apart more. In the case of the electroscope which we charged using the TV screen, the leaves spread apart more. That means they must have been negatively charged. As we said before, the charged object has the opposite charge of the electroscope, so the TV must be positively charged. Well, thanks for watching. Check out my YouTube channel, rimstar.org, for more videos like this. That includes the one on how to make your own electroscope, one on how inductive charging works, and one about charging things using the triboelectric effect. And don't forget to subscribe if you like these videos, or give a thumbs up, or leave a question or comment below. See you in a bit.